Hi, today we're going to talk about a chemistry topic and a chemistry term known as isotopes. Now, when you first hear isotopes, your mind might flash to The Simpsons, and you think of the local Springfield team and Bart and Homer. They go to watch them, and they're called the Springfield Isotopes. And the reason they're called the Isotopes is because Springfield hosts a nuclear power plant, and a nuclear power plant is probably the place you've heard the word isotope, but it's actually isotopes are everywhere. You're made of isotopes. I'm made of isotopes. It's just another word to be more specific when describing atoms. So, what is an isotope? Well, the actual definition of an isotope is this. It's atoms. Well, we'll do blue today. I thought I was in black mode, but atoms with the same number of protons. So they have the same number. Whoops, that's a number, the sign of protons, comma, but different numbers of neutrons. And so if you look at the picture below, there are two isotopes of sodium. And you can see that they both have 11 protons. So here we're going to... my writing is really messy. Okay, so they have the same number of protons, but they have different numbers of neutrons. So let's take a look down here at the picture. Here are two sodium atoms. Now, in the last video, we talked about the protons, electrons, and neutrons. Here, the picture of the atom in the book, and again, it's not really red in real life, but this would be the area where the electrons are. And I'm not going to say the name, but you should remember that place has a special name for the atom. And then in the middle of the atom, this is where 99.9% of the mass of the atom is located, is the nucleus. And inside that nucleus, we have protons and neutrons. So sodium will always have 11 protons. Remember, the protons determine the identity of the atom. And if you change the number of protons, you've changed the identity of the atom. It's kind of like if I change your DNA, you become a different person. However, in the nucleus, you can have different numbers of neutrons. So you notice this particular sodium has 12 neutrons, but this particular sodium, and we know it's sodium because it still has 11 protons, actually has an extra neutron. And so what we say as chemists is we say these are two isotopes of sodium. Another word you could use, and we don't use it, but it might help you think about this. These are two versions of sodium. They're both sodium. It's kind of like Coke and Diet Coke and Coke Zero. They all have the same basic concept, the same secret formula that's Coke. One of them doesn't have caffeine. One of them they substitute sugar instead. But in essence, it's still Coke, and it says Coke on the can for each of those. Well, these are both sodiums. The difference is they have different numbers of neutrons. Now, I want you to take a look at the way that this is written. Also, sorry, before we get to that, notice that the number of electrons in each different version of sodium is the same as the number of protons. And we talked about that in the last video, but that's an important point. The number of protons and the number of electrons for an atom, and for different versions of the same atom, different isotopes of the same atom, will always be the same. Alright, so if you look here at the bottom, this is the way that we write. We can expand our chemical symbols now. Remember, we talked a few videos ago about the symbols for the elements. Now let's take a look in particular at the way this is written. So I'm going to go over here and let's go switch to black. So this is, they write the symbol, and then there's two numbers here. And we'll see this a lot this year in both the book and when I'm talking about atoms and when you're talking about atoms, because this method here gives a lot of information. So the first thing, let's switch here, let's go. So let's take a look at this number. This number is called the atomic number. So this is an abbreviated. It's the atomic number, and it's the number of protons in an atom. It's the number of protons. So notice that these two isotopes of sodium, they both have the same atomic number, 11. So 11 for both of them. What about the number at the top? Well, this is called the mass number. So let's write this here, mass number. And it's the number of protons plus neutrons. Let me erase that. So it's the number of protons plus neutrons. And that's the mass number. So put a box around these. These are two very important terms here. Mass number and atomic number. We take a look at the two atoms down here. Notice this one, 11 protons, 12 neutrons, is 23. So it has a mass number of 23. This isotope of sodium has 11 protons and 13 neutrons. So it's going to have a mass number of 24. And you can see that is reflected here in the chemical symbol. Okay? Quick joke. We're going to move to the next slide, and there's one more thing, but a quick joke. And this is a chemistry joke, but look at the symbol of sodium here to get this joke. I could ask you, one chemist asked the other chemist, "Hey, have you heard any good jokes about sodium?" And the second chemist says, Nah. Have you heard any good jokes about sodium? Nah. Okay, because it is nah, but it actually stands for natrium, which, interesting, has to do with water. The swimming pool, natorium is what it's called. And I think at Nutria there's a sign even that says natrium. And that comes from the same Latin root word that sodium comes from. All right, let's go next. All right, a couple of things to touch base on. When you look at and we're going to talk in more detail about this, but when you look at the periodic table, so we go on the periodic table and we have sodium, and on the periodic table, at the top they'll have a number 11, and at the bottom for sodium they have this 22.99. On the periodic table, this is, of course, the number we just talked about. This is the atomic number. Okay, so for sodium, that is how many protons it has. But this number, we call this the atomic mass. And it's actually related to the mass number. Remember, the mass number is protons plus neutrons. So you might look at this and say, well, wait, protons, neutrons, and electrons, you can only have one. You can't have fractions of them. So how is it that sodium is 22.99? How can you have 0.99 of something? And the reason is because, as we saw in the last slide, sodium actually occurs in two versions. There's this version. There's actually three versions. I'm sorry. There's this version. And there's also a third isotope. So sodium has three isotopes. So these are the three isotopes of sodium. Here's 1 and 2 and 3. And I'm just doing this in no particular order just to add a little color, help them stand out. And basically, in nature, if you had 100 sodium atoms, let's say you had 100 sodium atoms, 98% of them would be this. 1% or one of those 100 would be that isotope, and 1% or 1 would be that. So again, if we had a stack of sodium atoms, if we had 100 sodium atoms, 98 would be this isotope, which has a mass of 23. But the reason this is not 23 is because some sodiums, and this is slightly higher than 1%, this one, It's like 1.1% maybe. It's an average of these three. And so when you average the masses of 22, 23, and 24, it's going to come out very close to 23, again, because most of the isotopes of sodium are 23, but there are two different isotopes that aren't 23, and that's reflected in this number. So this is an average. And we'll talk in more detail about that in a later video.